All right, let's take a look at solving radical equations, and basically what do we need to do to be able to get to that x. And so to start this guy off, we take a look, and obviously we have the radical, and so we need to get underneath that radical. I want to kind of compare these two, and so I won't go all the way into this guy on the left-hand side because I want to use him as an example to lead into this one. So in this case here, we're ready to go because we have isolation. And so we have the radical is isolated. And so we can just jump right in and say, okay, well, if we want to undo a square root, we square it because the square root and the square cancel, and that leaves us with 7x plus 30. Remember, in algebra with equations, whatever you do to one side, you have to do to the other. And so we come over to this other side and we square that. Excuse me. And so at this point, on this right-hand side here, we come off to the side, and remember we have 3x minus 20 squared. And so remember that means we actually have 3x minus 20 times 3x minus 20, and then we FOIL that together. So as we jump into this and we start working through, what we see is that, remember with FOIL, we take first, so that gives us 9x squared, outer, so that gives us negative 60x, inner, it gives us negative 60x, and last, it gives us positive 400. We combine like terms, we get 9x squared minus 120x plus 400. We bring that back up here and put it into place. So essentially I just did my scratch work off this side of the paper instead of having to write everything over several times. So at this point, hopefully, we talked about in the last couple of videos is that this idea that do you have a linear or is this a quadratic? And because this is a second degree here, then we know we have a quadratic. When we have quadratics, we want to take things and put them in standard form. And so remember standard form, that's where we're going to have ax squared plus bx plus c equals 0. So in this case here, we're going to move everything to the left-hand side. So we're going to subtract 7x, we're going to subtract 30, and then we'll simplify and do some housekeeping. The 7x's cancel, the 30's cancel, that gives us 0. We have 9x squared minus 127x plus 370. Now, one of the reasons that I choose to make my own videos instead of using the videos off of the textbook company is because at this point when they do the factoring, they really just jump all around. Like they just kind of expect you to understand. So my main thing I want to talk about here is how do I approach this? And so last week we looked at factoring, and that was so that way you would form some strategies to be able to be better at factoring quadratic. So when we come across something like this, life would just move a little more smoothly. So first thing is, let's see if we have any common factors. So let's see if 127. So 127 divisible by 3. Well, 1 plus 2 plus 7, that's 3 plus 7, that's 10, and 10 is not divisible by 3, so 127 is not. All right, that means 127 is probably not divisible by 9 either, and same thing with 370. So we know that in this case here, we don't have any common factors. We're ready to roll. So we have to do our product sum factor using our technique from last week. We kind of move some stuff around here. So if we do product sum factor, our product is going to be equal to our 9 times our 370, our A term times our C term. And so we have 9 times 370, and so that's 3,330. Our sum is equal to negative 127, which is our middle number, and our factors are what we're going to look for. So to find our factors, what we do, remember, is we go to y equals, we type in our 3,300 divided by x. We go to table, which is in blue, so second table, and we're looking for two numbers that add up to 127. So right there, 37 and 90. We put 37 and 90 together. So 37 and 90. If we multiply those, we get a positive. If we add them, we get a positive. So we actually need to make both of those into negatives. So now when we multiply them, a negative times a negative is a positive, and the sum would be negative 127. We bring those guys up here, we get x minus 37 and x minus 90. So we just literally carry those values up. Because this guy has a leading coefficient, this is why I call it bottoms up, we take that leading coefficient, we place it underneath, and we see if it goes up. We say, does 9 go into 37? And it doesn't. So that 9 comes right out here in front, not in front of the parentheses, but right inside the parentheses, and this becomes 9x minus 37. In this case right here, 9 does go into 90, so this gives me x minus 10. Okay, these are called my factors. Remember, that's not what I'm looking for. I'm looking for my solutions. So we take those factors and we set them equal to 0. So in this case here, we add 37, we add 37, we add 10, we add 10. So we end up with 9x equals 37 and x equals 10. We divide by 9. I'm getting a little lag there. Sorry about that. We divide by 9, we divide by 9. We come out of this guy as x equals 37 over 9. In this case here, we get x equals 10. So from this point right here, because we're dealing with radicals, and when we square something like that on both sides, we have the possibility of an extraneous solution, so we need to check. So when we check this guy, so this step right here we're about to do is the check. Go ahead and close this out just for a second. Get rid of that. So when we check this guy, we're going to take that original equation that we had from the very beginning, and we're going to test. We're going to test our two values that we have. So the two values that we have right now are x equals 37 over 9 and x equals 10. So we take that with our original equation. So we have the square root of 7 times 37 over 9 plus 30. And the question is, would that be equal to 3 times 37 over 9 minus 20? So I pull out my calculator at this point and I test out each side. So I go to my home screen, second quit. I take I don't plug in the radical personally, I just do as it is. So I say 7 times, open parentheses, 37 divided by 9, close parentheses, plus 30. So I know that right now I'm going to get this nasty decimal inside of there. I take the square root, second square root, and I can arrow up to grab that guy, press enter and enter, and so I know that when this guy gets simplified, he's going to be approximately 7.66 repeating. Now this guy over here, that would be 3, open parentheses, 37 divided by 9, close parentheses, minus 20. So that is negative 7.66 repeating. Those are not equal. Therefore, I know at this point that that will not be one of my solutions. So I go on to the 10. I do the same process. So I take the square root of 7 times 10 plus 30. I set it equal to 3 times 10 minus 20. I test the left-hand side. That's going to be the square root of 100, which would be equal to 30 minus 20, which is 10. And so 10 equals 10, and that's check. That's good. That means that guy right there is my solution. So I have one solution to this equation. So that's quite a bit of work. That's the process. Is that to eliminate the radical, we have to isolate the radical first, and then we square, because the inverse of square root is a square, and that undoes it. And then from there, there's consequential algebra. All right, now just real quickly, I want to address a conversation about this guy, because he's slightly different. He's the same process, the same deal as far as setup once you get going, but they're not, the radical and the x are on the same side. So the first thing we need to do on this guy is we need to move that entire expression to the other side. And we can do that. I mean, I need you to be comfortable with the fact that that can be done, that that is a legitimate step. So I get x, those cancel, equals 12 minus 4x square root. So remember, once again, we're back at where we were a minute ago on this guy. So I'm not going to do all of this problem. I'm going to go dot, dot, dot in just a minute. But the whole point is here is I want to get rid of that radical. The inverse of taking the square root is to square something. So the square root and the square cancel. Whatever you do to one side, you have to do to the other. So now I have 12 minus 4x is equal to x squared. And you just continue on down that. Oh, we'll go one more step. So in this case here, we want to be in standard form. Remember, standard form is ax squared plus bx plus c, because we can factor from that form. We can use a quadratic formula from that form. So we move the 12 over. We move the 4 over. And now we're ready to roll, because now we have x squared plus 4x minus 12 is equal to 0. So you can do product sum factor on this if you want, however you want to approach it. So if we did do product sum factor, my product would be negative 12, my sum would be positive 4, and my numbers would be 6 and negative 2. So x plus 6 and x minus 2 is equal to 0. So that means x plus 6 equals 0, x minus 2 equals 0. So x equals negative 6 and x equals positive 2. So don't forget, we need to check those. So we come back up to our original equation, and we're going to do our check. Over here, oops. We're going to do our check. And so we take that 6 and we plug it in. So that'd be 6 minus the square root of 12 minus 4 times 6 equals 0. So that's 24 minus 48. I'm sorry, 12 minus 24, that's negative 12. That equals 0. And so that is not going to be a solution. There's no way that that's going to turn out to be equal to 0. So we know, in this case here, that negative 6 does not work. Oh, wait, I did something wrong. Excuse me, let me back up on that. I'm testing negative 6, which means I have to slide a negative sign in right here. At that point, what happens is I end up getting 6 minus the square root. That'd be 24 plus 12. That would be 36. So that'd be 6 minus 6, and the answer is 0 does equal 0, so check. That actually is one of my answers. So let's rewrite that. X is equal to negative 6. We test out the 2, same process, same idea. So we test that guy out. So 0 is equal to 0. That's good. So we test the next one out. We plug in, we're plugging in positive 2. So that would be 2 minus 12 minus 4 times 2, all under the radical, is equal to 0. So that's 2 minus
12 minus 8. 12 minus 8 is 4. So the square root of 4 is equal to 2. So that's negative 2 is equal to 0. That is not true. Therefore, x minus 2, or x equals 2, is not one of my solutions. I'd have one solution, and that would be that guy right there. All right, so that kind of takes a look at what we do when we have radicals on one side or possibly both sides, and how we eliminate that radical and then solve.